Hi everybody, I'm Steve Scalpone. I'm from Nvidia. I'm the manager of the PGI Tools and Compiler Group, and I work on Flang. And I'm going to give an update on what we've been doing in the last 6 months since the last update I gave in Bristol. Flang project is open source Fortran compiler, front end for LLVM. And PGI and the NNSA labs are doing a joint project, 4-year project. We're entering the last year right about now. And based on the PGI compiler, we re-engineered it to work with LLVM. And one of our goals is to provide a top quality Fortran compiler like Flang is for a C, C++ compiler, et cetera, et cetera. And one thing we found is that it's hard for people to get into Flang. It's hard for us to refactor things, so it's in libraries. It's a big monolithic C program. So what we decided to do is rewrite it. So Nvidia, in open source, is rewriting a Fortran front end. We call it F18, but it's going to be Fortran 2000, Fortran 2003, 95, 77, all the Fortrans that people expect, plus vendor extensions. Written in modern C++, mostly C++ 17 is the base structure. We're using Variant to do a lot of everything we've done. Tracking high-quality source locations in a scanner, preprocessor. We're building ASTs and not lowering them, not losing information until after semantics. So people should be able to build some great tools there, and we're talking to people about that all the time. What you can see is that the PGI intermediate is gone. It's going directly to LLVM IR. And that's moving right along. We're through parsing, we're through pre-processing, we're doing semantics of most all declarations right now. We've done expressions, lowering representation of expressions, and we're starting to work through loops. We've done do concurrent already. So it's going pretty well. Taking volunteers, we're having a meetup at 3:30, a roundtable discussion. So come on by, say hi. Say the project right now, it's been open source for over a year now. We continue to push things out. We pushed about 1,200 patches out there. Maybe 100 came from the community. So there's not a lot of involvement, but there is some involvement. Mailing lists, Slack, GitHub issues, it's all there. There's the URLs right there. Keep a roadmap up to date, submission policies, community. It's a pretty normal open source project right now, even though Nvidia does the vast quantity of the contributions. Performance is good, and we can attribute almost all of that to LLVM. We use LLVM OpenMP runtime. We use LLVM code generator. We've done some work with vectorization. But you can see on the spec 2012 OpenMP benchmarks is the Fortran subset that were better than G-Fortran. And we are not as good as PGI, but you can track that all down to the first number in the middle column there, the 71. There's a pretty complicated loop that has conditional vectorization that almost all the processing happens in. And PGI can catch that, but LLVM can't catch that yet. So we're still working on that. Target offload was another big thing we're working on in OpenMP. We're targeting the, look at my countdown timer. You looked, I looked. So OpenMP 4.5 is a way to specify a program that can offload to a GPU, so computational units. And that work's been done in Clang. It was done in IBM Yorktown's done a lot of it, and they pushed it into LLVM 7. And we're fast following that with Flang's implementation. Right now, we're focusing mostly on the combined constructs, target teams, distribute, whatever. That's because they're really set up to do good performance on a GPU. That code's not quite pushed to open source yet, probably in the next week or 2 weeks. We did submit a paper that was accepted to the LLVM HPC workshop at SC18. We're going to try to get a preprint on the GitHub site sometime before then so people can see it. We'll send it out to the mailing list as well, so you can see what we did, how it compares to what's in Clang. Other things we've done in the existing open source, we continue to work on that. That's where we're pushing most of those changes that we wrote about. We've implemented submodules, do concurrent, which is a way to do an unordered loop. So it can normally, they think that it's going in parallel, but really the definition is that it happens unordered. Last year we talked about, in Bristol, we talked about the PG Math open source runtime, which is the PGI and the Nvidia intrinsic library, sine, cosine, masked, vectors, and scalar versions of that. Since then, Cavium contributed a AR64 ARM version of that, and that's in the open source now as well. And then once we had those mask routines in place, and once we had the vector routines in place, we added code into veclib support so we can get vectorization of those routines as well. We continue to enhance the LLVM metadata for debug as well, so we can get Fortran debugging coming out the back end in Dwarf. A lot of work's going on there. And that's it. We have a roundtable at 3:30. Thanks.